Right. So yesterday we have gone up to here. Yeah, we have stopped here. Yesterday we have stopped here. Land capability classification. So we will continue. We will continue here, and then we will continue. Yeah, this one. So capability classification, we have how many categories are there? The capability consisting of three categories, students. What are those? Capability class, capability subclass, capability units. So these are the three categories present in the LCs. So these are the parent. Now we will see one by one. Subclass is nothing but which factor is limiting. We will put that factor. Units means is nothing but the similar fashion of size comes under one unit. That is true. That is what including all these things. Now we will see students LCC capability classification. This is what students. Remember LCC, land suitability, suitable for cultivation. So remember students, in land capability classification, there are totally 8 classifications. First 4 were suitable for cultivation. So we can grow for normal agriculture crop cultivation. What are those? LCC1 class 1, which is represented in green color in map. If the land is comes under green color, sorry, green color, that part, that the particular position of map or land is very good. It comes under LCC. And LCC2, that is class 2, which is represented by yellow in color. So if in map, if you represent anything in yellow color in particular land, that particular land comes under the LCC2. The same time, class 3, that is LCC3, that is in brown color. If you represent anything on map and brown color in particular land, that belongs to LCC3. LCC mostly, most of our soils we can see, mostly we can see LCC3, we can see in some extent we can see LCC2. LCC1 is impossible because every land has its own demerits. I think hardly we can see LCC1, but LCC2, okay, we can see, but LCC3 is quite common. And LCC4 students, it is represented in pink color. That is class 4. If anything in map, any land was represented in a pink color, this comes under the LCC4. So fairly good land on almost level plain. So we will go all these things. So these are the different classes students. The first 4 classes LCC1, LCC2, LCC3, LCC4 are suitable for cultivation, so we can go for good cultivation students. Now if you go to the description of this particular LCC2 1 2 3 4, we can see what good, this is very good, lands are very good, cultivable, we can go for very good cultivation. Deep, it's also very deep, nearly almost there is a level plain, very productive land with at least no limitations. There is no limitations at all, very little. There is also, that is very nominal, very little hazards will be there. No need of any special management practices for cultivation. Just we can throw the seeds, it will, crop will grow. Can you found this type of plants anywhere? LCC1, is there any possibility? Any possibility students? Please answer, is there any possibility but we can find this type of plant? Very good, cultivable, even there is no limitations. No need, we need not to take care any special management practices for cultivation purpose. Is it possible? Not possible. It is not possible. If we come to the next one, LCC 2, that is class 2, which is represented yellow in color. See this one in description. Here it is very good cultivable land on almost level plains. Here it is also like it is nearly level, it is almost level, or on somewhat we can some extent we can see some gentle slopes. There will be a slight limitations like soil depth will be somewhat limitations will be there, salinity, texture, drainage problem will be there. But those problems are very slight, very minor limitations will be there. Cultivation, we need some precaution, we need some sort of management precautions with a very simple management practices. There is a possibility we can see this type of plants, but very limited ways. But this is one very impossible. This one is impossible, but two we can see. So this is what regarding the LCC class 2. But LCC 3 students, almost moderately good cultivable. We can go here also almost plains on moderate slopes. We can expect some moderating sloping is there. Limitations are under moderate conditions like erosion, soil depth, salinity, soil texture, cultivation with. We need a very careful management practices and need a very intensive care. If you want to go for any crop cultivation, we have to take very care. We need a very intensive care regarding the class 3. class LCC3 classification. So we need very intensive regarding the LCC3. Coming to the LCC4 students, see the conditions. Here, sorry, yeah, here fairly good land. Land was very good, almost level plains, moderately steeping, and you can go for very occasional cropping only, students. We can go for very occasional or limited cultivations only. We can go. Generally, this type of not suitable for very variety of crops. We can't grow all type of crops. We can go very some specific crops only, because of very strong salinity. There will be shallow depth will be there, erosion problem will be there, texture somewhat will be very poor, excessive drainage will be there. So soils, if you, even if you try to go for crop cultivation also, this may not be economically feasible for cultivation, economically not feasible for cultivation. So it is not feasible for economic cultivation. This is a problem in class 4. Now see, students, so these completely class 1, 2, 3, 4, which are suitable for cultivation. Somehow, whether it's good or bad, we can go for agriculture cropping system. With the color, please remember, students, you may get some questions in this color. Is important for both the section of students. Green color means very good. Just to remember, like the green color is very good. Yellow somewhat good. Class 3 somewhat moderately good. Class 4, it is represented in pink, fairly good. Just to remember, green, yellow, brown, pink. Just remember the class colors mapping, because after drawing map in if any map, whether digital map or any handwritten map, they will give some coloring. So this color will give the special meaning for that map. Okay, students, this is regarding the land suitability cultivation. Now we will see land unsuitable for cultivation, but simply suitable for permanent vegetation. We can go for permanent vegetation, or we can go for from forestry, some grazing purpose. What are those classes? Class 4, class 5, class 6, class 7, class 8. So these classes are suitable for only what purpose? For permanent vegetation purpose. We can go only for permanent vegetation, permanent grazing, for cattle grazing, or sometimes for recreation purpose, or sometimes for forestry purpose, like that. So, but we can't go for any cultivation. But previously, four categories are good for cultivation. But these four, the next four, class 5, 6, 7, 8, are not suitable. What is the color, students? Class 5 is a dark gray color. Only it is represented in dark gray color. Class 5, sorry, class 6 is represented in orange color. Class 7, red, very danger. So red is indicated as red danger. So class 7 is indicated as red. Class 8 is represented in purple. It is represented in purple color. So remember this color. Now coming to the description of this particular LCC categories, classes or whatever. So class 5 will says these are not suitable for arable farming. We can't go any farming. But it is very good for grazing purpose. That too we have to go with the limitation. We have to be very careful. And the only problem in this land is, student, because of there will be heavy stoniness and rockiness is there to move the implements. If you want to move any agriculture implement, there will this type of lands will be very rocky and stony. So it is very difficult to move the agriculture implement. This is a problem. But this type of soils are good for no, not good for arable farming, but good for grazing. We can go for animal grazing, all those things. Next, students, class 6, which is orange. This is also non-arable. We can't go for any cultivation, but well suited for forestry use also. Both grazing and forestry, both we can use. Somewhat we have some moderate limitations. Coming to the limitations, even if there is we can go for these purposes, grazing and forestry, there is some sort of limitations, such as steep slope will be there, severe erosion will be there, so limited soil depth, strongly gypsiferous, stony and sand dunes will be there. So you can see all these problems. You can see some gypsiferous problem will be there, some stony problem will be there. This type of land suitable for grazing and forestry only, but have very moderate limitations of these so-called limitations. Coming to this 7 is a fairly suitable. These soils are not that much good when compared to these two. These are not that much suitable for grazing, but we can go some extent. Very fairly suitable for grazing and forestry. These soils are not at all cultivable, having very severe limitations of steep land, subjected to the erosion. There will be erosion. Very shallow depth will be there. Stones and soils will be there. Not having moisture availability is very less. So we need a very careful management if you want to convert this land for grazing and forestry. So we need a very careful management practices in class 7, which is represented in red color. Final classification, that is final class, that is class 8. So these are all non-arable, extremely rough students, rocky, arid, wet and extreme. See the statistics: wet and extremely saline land, suitable only for wildlife and recreation. We can go for only some recreation purpose. We can go with recreation. We can go for some park construction, etc. And some wildlife protection conditions we can go. Having very severe limitation, for instance, having eroded land will sometimes land will be eroded. Sometimes maybe this land will be on mountain tops, rocky undulating surfaces, very rocky, some undulating surfaces will be there. So this is regarding the condition in LCC 8. So these are the five systems of five LCC classes which are suitable only for permanent vegetation and grazing. That too in last classification we can go only for wild recreation purpose only. There is a severe limitations because sometimes these lands will be on mountain tops, rocky undulations will be very high in this type of LCC 8. So this is regarding the LCC classifications, land capability classification. Remember these colors and just give maintain some key idea regarding about these classes. Then you can go for, you can attempt good very correctly answers in examination. So next students, land capability subclass. So nothing students, just if you see land capability subclass means nothing. If you after classifying all the soils, after getting all full knowledge on particular soil, you found that one particular soil is facing some erosion problem, and you will mention that that soil is comes under LCC 2. LCC 2, see LCC 1 is not there, we can't find anywhere, but you can say LCC 2 and 3 very regularly. So you will say land comes under LCC 2, but there is a limitation of erosion. You will represent it as class 2E. You will give symbol E. Symbol E means that particular soil is facing some irrigation problem. That is what is the limitation factor in that particular land or particular soil. That is what representing in this year. If it is water condition is not there, then you will mention particular class, which class is there. Then you will mention in subscript you will say W means water. There is some excess water problem is there, some wetness problem is there. So this is what called the land capability subclass. Coming to the next students, land capability units. This is nothing but students, uniformity. You know, if there is if the soils are very similar, very uniform means, then we'll group all the soils in one particular. So we'll kept all this particular soils or group all this particular soils in one unit, that is called the land capability units. So the land capability units are sufficiently uniform. So which type of character should be taken into consider? So these three are very important. What are those? To produce, so what is the need for that? To produce similar kind of plants with similar management practices. See students, if you, for example, if you found the soils of in particular area in Uttar Pradesh, see you say that the soils are having this type of limitations. There is some salinity problem is there. Say some neutral salts or some magnesium carbonates of calcium and magnesium are present in Punjab also. Then what you will say, okay, these two are, then you will group all these soils in one unit. Then you will give similar kind of management practices. What are those practices? So these are the practices to produce similar kind of plants with a similar kind of management practices. Very simple. So you can recommend the similar kind of practices of both the areas. So require similar conservation treatments and management. Just now I said. There in salinity, we can go for subsurface drainaging, while leaching out with salts, with good quality of water, we can go with similar kind of management practices. And also the land capability units, LC units, can be used directly from farm planning to and their uses. This is a major point. So we can plan the crops. So what we can give what kind of plant should be given there, what kind of planning should be, farm planning should be there. We can give and we can recommend the farmers in a very directly manner. So this is called the land capability units. Remember this. What is the meaning of land capability units? Thank you, students. And coming to the next is land irrigability classification. This is what, students, this is what very important thing. So this is for SRF students. This is up to here. JRF students is up to here only your syllabus, JRF syllabus. But from here after, there is completely SRF syllabus. Land irrigability classification. I'm going to ask you one question. Can anybody answer? So already almost there are almost very good attendance are there today. Anyhow, so nowadays government of India was trying to bring much land, whatever the land was not under irrigation, they're planning to bring that land under irrigation by connecting the rivers, by connecting, especially Andhra Pradesh has connected both Krishna and Godavari and converting most of the under irrigated area into irrigated area. Is that good or bad? Can anybody answer? Is that good for the environmental condition? Is that good? Is that good? No one is answering. See, bringing a new land, is that good? Is that good for the environment, or is that good for that particular soil? Can anyone answer? Good or not good? Just only two answers. You can choose. Come on. Okay, should I pick the person who will say the answer? 1, 2, 3. Okay, 3 students are there. Okay, Ramya, could you answer?
Good, sir.
Okay, Ramya is saying, okay, sir, soil is very good. Bringing one land into irrigation is good. She is saying good. Okay, Krishna Kumar, what is your answer?
Sir, I think this is good for farmers, but it depends upon the quality of water and the source of water from where it is coming.
Quality of water, generally Ganga water is very nice. Up
Yes,
to my
sir.
knowledge, all river waters of India is good at present.
Yes, yes, sir. So it is good.
So it is good
for
or bad?
irrigation. Good, sir.
Okay, okay. Bringing a new land is good for irrigation, you're saying?
Yes, sir.
Okay. Okay, 2 SRF students are gone. One more SRF student I missed. Yeah, Mr. Rai, what about your answer? That is good or bad? So two students said it is good. What about your answer?
So I'm not getting your question because there was some network issue and your voice is disconnect sometime.
Okay. Okay, okay. So bringing a new land to irrigation is so I am bringing a new land under irrigation by connecting rivers and all those things. Is it good or bad?
Sir, I think, sir, it's good or bad both because it's depend on that irrigation water, which type of water we irrigate and their environmental condition also. So
irrigation water means we are using river water only. Mostly our Ganga and Mahanadi, Godavari, Kaveri, all are good water. I think so. There is no that much pollution. India was not become that much worst at present.
yeah, sir, it's yes, I'm getting it good water, but sir, there were some environmental pollution also responsible because we can't say ki, it's pure. It's pure 100%. Also, there were some contamination also. So
What
I think,
kind
sir, it's good or bad both.
So you are in a two-minded. Okay.
No, I'm not two-minded, but I think there were some also drawback also. So
what kind of
you
drawbacks
said,
you are
what's your
expecting?
opinion about that?
What kind of drawbacks can you expect if you bring any new land under irrigation? One you setting that quality of irrigation water. Okay,
Yes,
I may concern that because
yes,
if there is nearby factories may dissolve their highly heavy metal contamination. Okay, we will consider that one also. Is there any other problem?
no, sir, I think.
Okay, students, if you go very scientifically, if you go very in deep regarding the science means bringing a new land under irrigation will create some many problems, some many problems. it is while irrigating, you can expect some new weeds will be grown, new problems will become, the soil, new soils will be developed. Sometimes if the particular soils are highly rich in some sort of calcium resources, what will happen? The soils may those particular soils may convert into saline soils. All those problems will be there. Actually, this type of this problem will learn very in deep in problematic soils. Whenever a particular land brings under irrigation, we can expect some imbalance in salt. No, so salt water balance. We may read in problematic soils. There will be some problems. Definitely, there will be some problem. That's why while bringing any land under irrigation, we have to do thoroughly, we have to do a very detailed survey, high level detailed survey with high intensity we have to do. Then only we should bring any land under irrigation. Otherwise, we may face new problems. Sometimes you can see some new weeds may be generate, because up to then the land was completely dry. So what happened? More evapotranspiration, all salts will be there on the upper layer. So all of a sudden, if we give water, all of a sudden, if you open the water to that particular land, sometimes we may expect some salt problem also. We can expect some salt problem also. Anyhow, that is a different subject. We will deal in problematic soils. Let's come to our today's subject. This is what the discussion, right? See how many things we are learning. Good. Anyhow, students, land irrigability classification. So students, so irrigability classification, mostly grouping the soil. So soil units are first grouped under soil. So to evaluate the suitable mapped soils for sustained use under irrigation, the soil units are first grouped into soil irrigability classification. So to group under this land irrigability classification, we have to go for first we have to know the soil irrigability classification according to the kind and degree of limitation of sustained use of under irrigation. So very first, students, we want to see what is the irrigability. What is the irrigability of particular soil? So irrigability classification, either land or soil, three factors are concerned, students. What are those factors? Very first, students, drainability of the land. See, now you should think very critically. Drainability of the land, predicting the effect of irrigation water on yes, as you have mentioned recently, both two students have mentioned about this point, predicting the effect of irrigation water on salinity and alkalinity status of the soil also. This is what I said. If there is a salt, there is salt also under equilibrium conditions with irrigation water. So simply it is nothing but salt water balance, which we will read in a coming syllabus. So cost of land development. Another one also, cost of land development. If there is a bringing water, and bringing water is high costly when compared to the cultivation of crops, means that is not worthy for that is not an effective usage of land or soil. So very first, students, we will see what is the soil irrigability. What is the soil irrigability? So suitable criteria for land irrigability, soil irrigability or land irrigability. Suitable criteria. What are those criteria, students, for land irrigability? What are the basic criteria we have to take? The availability of water holding capacity, how much the water will be held by the water by that soil, effective root zone development, how much depth the root will be developed. This is very important. And water intake characteristics of the soil. What are the intake water characteristics should be taken. And also, students, the system is completely based on the limitations of different land characteristics also. We want to see we have to study some characteristics of the lands. What are those characteristics, limitation characteristics? We have to read the texture. We have to see the depth, because we have taken one criteria, very important criteria, root depth, and also permeability, salinity, topography, and their appraisal for irrigation purpose and other appraisals for irrigation purpose. Overall, students, land irrigability classification units are grouped under these 6 classes. What are those 6 classes? Very, very important, students. Please remember these lines, and please remember these 3 points also. Based on these criteria, availability of water holding capacity, effective root zone depth, water intake characteristics. So these are the 3 important characteristics, and completely there are 6 classes are there in land irrigability or soil irrigability classification. We can expect 1 to 3, 6 characteristics. So very first, class 1 to 3, what is the condition? Just see the description. Arable, suitable for irrigated agriculture with nil to moderate limitations. They're almost there. Neither there not be any limitations. If so, there is a limitations also. It will be very moderate, very nominal will be there. And coming to the class 4 students, this is up to class 3 students, up to class 1 to 3. This is a conditional land irrigability classification. And class 4, what is the condition? Restricted arable. We can see some restriction will be there with the severe limitations of this. There is a limitations of very severe land not irrigable except under the special conditions. So in these conditions, there will be a restriction of variability will be there. So land can be irrigated only under very special conditions only we can done. Coming to the class 5 students, undetermined. We can't determine Here at least there is a there is a restriction. There is particular season restriction, but here you can't expect what will happen. So land having severe limitations, very severe limitations of what is that? This is the problem, students. Soil salinity and drainage. This is what my main intention in my explanation of you. So soil salinity, drainage for irrigation purpose. So in class 5, you can expect this type of very severe limitation of salinity and drainage for irrigation purpose. Whereas class 6 students, it is non-arable and unsuitable for irrigation. Class is pakka, there is no use. We can't give any irrigation. If you try to give irrigation also, it is not economically feasible. The cost will be very high. So there is no use of giving irrigation for this particular soils. So this is regarding the land irrigability classification classes. Class 1 to 6. Very first 3 classes are good. We can go. 4 have some restriction, but 5 have severe limitations of salinity and drainage conditions. But class 6, very bad. We can't even go for irrigation purpose. That is a difficulty in land irrigability classification. Now we will see what is that. So criteria of land irrigability classification. What is the major criteria? This is what land irrigability classification worked out based on soil irrigability classes. We will read this, and topographic conditions and drainage. Students, especially SRF students, now some tables will come. You please take your running note and please note down that table. That is very based on that table, you will get many questions. Okay, students. So based on land irrigability classification is completely based on work. These are the classes which is given. But based on these 3 characteristics, there are many subclasses are there. So very first we'll go for soil irrigability class, topography and drainage conditions. We will check all these 3 important characteristics of land irrigability classification. So very first we will see soil irrigability class. What is the soil irrigability class? So soil irrigability classes. So students, don't confuse. Land irrigability classification is depend on soil irrigability classification, topography and drainage. And these are the some peculiar characteristics, and these are the classes. So okay, student, don't confuse. And in soil irrigation, so before going to this land irrigability classification, we have to check the soil irrigability class. That is important. So it's for soil irrigability classes. There are, how many are there? There are 5 classes are there. A, B, C, D. Soil irrigability classification. What are those? Moisture, based on the moisture only. None to slight soil limitation for sustained use of under irrigation. There is no, almost there will be no any limitations for sustainable irrigation. But in B, we can say some moderate soil limitations will be there. Whereas in C, there will be severe limitations will be there, soil irrigability classification. In D, there will be very severe limitations will be there for sustainable use of irrigation. Under E, it is unsuitable for irrigation. This is soil irrigability classification. Please note down these lines, these points. So none to very slight. We can't say any limitations, but here you can see some moderate limitations. But in C, we can see severe. You can see here very severe. In D, in E, you can see unsuitable for irrigation purpose. Now we will see, this is what I'm mentioning, students. Please, this is what. So criteria for developing soil irrigability class. What based on which criteria we are going to see the soil irrigability classification. So these are the things. So we know what is A, B, C, D, E, which is I mentioned here. I mentioned here. Now we will see what is this A, B, forward. So based on soil properties, under which class, which character should be present are presented here. So please go down and please open your note and please draw this table. Very important. Please make some basic idea regarding with this. Okay, students. Now we will see effective root zone depth. In A class, there should be more than 95 centimeters. But in B, you can say around 45 to 95. In C, we can see 22.5 to 45. In D, you can expect 7.3, very limited. But here you can, that is why you can see these 2 are very difficult to, very severe to unsuitable. This is the case on this. But here, moderate, difficult. That is what now? Severe, here it is moderate, severe, very severe. What I mentioned here. So 22 to 5 is very depth, 7.5 to 22. Between these 2, but it is less than 7.5. Which one? Effective root zone depth. Surface, what is the texture condition, students? What is surface texture? You can see loam texture. Sandy loam to clay loam you can expect in A. That is why because of more depth. Whereas loamy sand and clay between 45 to 95. Whereas in C, you can see sand and clay. Or here also sand and clay. But E, you can see some other texture. Here sometimes the only sand will be there, so it is not suitable. So you see, just remember the sandy loam to clay loam. Here loam, sand and clay will be there. But here both you can see only sand and clay, C and D. Whereas E, you can expect only other conditions. Permeability, students, millimeters per hour. You can calculate this millimeter by a doubling method. 5 to 50 millimeters per hour. Here you can see. But here you can see permeability 50 to only 130. 132 to 250, but here is more than 250. Here also it is somewhat more than less than 251. Both are. Here in conditions, water holding capacity was more than 12 centimeters, but here 9 to 12, 1 to 9, 2 to 9, and less than 2. So you see these two are very limiting here also. This is also somewhat very limiting will be there. Coarse fractions will be less than 5, 5 to 15, 15 to 35, 35 to 65. It is less than 65. Sorry, more than 65. And root outcrops, so distance per millimeter. How many root outcrops? Root outcrop means distance in meters between the two crops. How much we can maintain? 40, we can maintain 20, 15, 5, less than 5. And salinity conditions, students, here it is less than 1. EC conditions. It is 1.2 to 1.5, 1.5 to 2.5, 2.5 to 3, 3. So 3 means we can't go very, very high salinity will be there. Exchangeable sodium percentage, very less, but here we can see both of these three are very high. Sodium was very dominated and structure conditions was very, very less. But here you can see sodium content was very less than 15. Exchangeable sodium content was very less than 15. This is the condition. These are the main criteria. Based on this data only, the soil irrigability classification has been done. Okay, students, please note down this table and make some critical idea regarding with this type of data. These numbers will be highly confused during examinations. Up to now, I didn't face any such type of questions in JRF SRF, but be careful. You may get some questions this point here also. So coming to, shall I move to the next slide, student?
Yes, sir.
Okay. Land irrigability classification. So finally, students, land irrigability class. So we have seen soil irrigability. Now we will see the criteria for how the land irrigability was done. So this is what, students, 1, 2, you know what is meaning of 1, 2, 3. We have read all these things about 1, 2, 3, some problem with 4, 5, 6 are some characteristics. So in land irrigability classification 1, we can see soil irrigability characteristics, like we can see A characters, we can see soil irrigability class A characters, we can see topography is less than 1%, we can see drainage outlets will be available, groundwater will be more than 5. This is the condition of land irrigability classification 1. This is 1. Please remember. And coming to 2, you can see A to B, you can see combined properties of A and B. In 3, you can see A and C, you can see. In 4, land irrigability classification 4, you can see A and D. 5, there is no research. We have to go for further investigation. There is no data. Coming to the E, you can see some E characters. We can see in 6, class 6. In topography, it is very less than 1, but here you can see 1 to 3% topographical bending is there, and 3 to 5 here, 5 to 10 here. Yeah, as usual, there is no data here. It is more than 10. Drainage conditions all available up to 3. Both are good, but in this here you can't expect any. And drainage condition was very less. Groundwater is more than 5 students here, meters of table. But here it is only 3 to 5, 1.5 to 3 here. It is less than 1.5. It's less than 1.5. These two classes. So this is regarding over a picture of land irrigability classification. In land irrigability classification, we have to, before going to land irrigability classification, you want to know the soil irrigability classification. So in that we can see some classification. Then in that, then we can go for topography, drainage. So by knowing all these characteristics, we can conclude that one particular soil, what is the condition of irrigation there. So based on irrigation, if the irrigation is any problem, we can give some integer for that, and you can keep that in a LCC classification. If there is an irrigation problem, so if there is only water problem, you can put LCC 1 subscript W. That is called subunit. So you may know all those things. This is regarding land irrigability classification. The detailed land irrigability. So overall, students, this is overall picture. So I'm giving overall picture of land irrigability classification. Suitability is irrigable conditions. We can see 1, 2, 3. We can go for irrigations. The subclasses depend upon the natural limitations. So in one conditions, we can see some limitations. But in the moderate limitation conditions, the subclass limitations, what are the limitations? Sometimes we can expect some soil limitations will be there. Severe limitations. If you see any severe limitations, subclass 3 of land, what is the subclass? That those limitations are concerned topography and drainage only. Restricted arable, provisional, not irrigable. We can see very severe limitations of soil, temporarily not suitable and suitable. So this is a condition of irrigability. So these are the irrigability, restricted irrigability, provisional irrigability. These are the classes. Suitability comes under the class 4, 5, 6. These are the conditions. Temporarily not suitable, but it completely here 6 is not suitable. This is regarding the land irrigability classification. Coming to the next, students, land irrigability subclass. Just now I have said it is nothing but just we are showing the limitations. Say for example, you have any limitations, just like as similar to the land capability classification subclass. If there is any limitations, just we'll place that limitation factor in the map. If you have any drainage problem, we will put as a subscript as drainage. If you have any topography limitations, we will put as TS in the subscript. So class 1 T. If you put T, class 1 T, if you put means okay, the soils are limited with topographic limitations are there, drainage limitations are there. We will see all those. That is the meaning of land irrigability subclass. Subclass units, similar students, just similar to the land irrigability, land capability units. Just will group all the lands which nearly likely to be irrigated. So the similar irrigation cap will group it, and we will use similar crop adaptations. We can get good management practices. So this is very quite common with soil irrigability classes and land irrigability classes and land irrigability subclasses. So subclass and subunits all are quite similar to the land capability subunits, land capability units. So that is the meaning of this. That is the meaning of land irrigability units. Coming to the next, students, irrigability approach. Finally, we are coming to the irrigability approach. This is very important. This is another important aspect. Especially this is present. All these are present only in SRF syllabus. All this land irrigability XYZ. Irrigability approach. This is also thing, students. So overall, students, in 1972, SAIS, one scientist is there. He qualified one irrigability, given some irrigability approaches, and proposed a few parameters for evaluating the suitability of soil for irrigation. What are those parameters? He given 7 parameters, students, to go for irrigability approach. To give an irrigability approach. What are those? Soil physical and chemical properties. What he has given it? Those properties are texture, availability, water holding capacity, salinity, calcium carbonate, gypsum content. So he given these characteristics. And another drainage, he also proposed drainage conditions. What are those? You should check the internal drainage conditions and permeability and intake rates and topographic conditions, natural slope. If you just rewind what I have said in the previous, you can see all these characteristics. But this person said that he just given some proper explanation, proper classification. So now we will see what is irrigability approach. So overall, students, this is what students. So capability index. There is one formula. What is this capability index? CI is equal to A into A, B, C, D, E, F, G. So all these characteristics. You can see what is those things. A, B, C, D, E, F, G. These are the notations. So each one have their own meaning. A means rate of soil texture. B means rate of depth. C means calcium carbonate status. What is the condition of calcium carbonate status? And gypsum content. D means E means salinity and alkalinity. F means drainage. G means topographic conditions. So by calculating all these things and by multiplying all these things, we get one index that is called the capability index. This was given by this person, SAIS, in 1976. This is a irrigability approach. He given one approach. So soil site suitability evaluation of crop, students. So another thing is that just giving site suitability means, so not all crops will have similar conditions, students. Every crop needs some different soils, whatever. So even though there are some crops are there, they can grow in very extreme climatic conditions, but not true in all cases. That you have some different. Say for example, the deep forest respond differently to soil depth and texture than the shallow rooted crops such as wheat and rice and sorghum and pigeons. So this is here we will go another classification called soil site suitability. Which soil is suitable for the agroclimatic conditions or plants? We will see all those things. And this is also based on availability of water, plant nutrition, largely controlled by the physical, chemical, and microbial environmentals of the soil. Now we will see what is the conditions. Suitability criteria for different crops. So students, for cultivating different crops, most of the plant needs a well-drained, students, especially horticulture crops. We need a very good well-drained crops. So moderately fine texture is almost suitable, and that should be very free from salinity and having optimum physical conditions. So for this land evaluation, for the different region, we will read 3 approaches, students. One is called the index proposed by the Stories in 1954, index proposed by the Ricker in 1970, and third one is FAO, that is Food and Agriculture Panel of Land Evaluation for the crops. So different crops in different things. So in that there are different proposals are there. Index Stories proposed one index, Ricker proposed one index, and FAO panel was proposed one index. Now we will see everything. And students, remember, SRF students, be careful. At least I'm expecting one question from these three things. Very be careful. And there will be one table here also, one table will come. So please note on that table also. I hope you are following. Is it okay, students? Are you following?
Yes, sir.
Please follow. This is SRF syllabus. Please follow. Now we will see the index proposed by the stories. Stories index. Mainly 4 factors are there. What is those? ABCX. See, students. Stories. What is the meaning of A? Index on characteristics of physical properties. You want to see, so you will give some first index is given, more important physical properties. Rating on base of soil texture. Rating based on the soil slope. Rating on conditions of other than those factors. These three factors like drainage, nutrient index, level, erosion. So X is nothing but other than these three. All are included in X. This is what given by a stories index. So students, stories by calculating, by doing all the analysis in laboratory, everything, by doing survey, all type of survey, everything. Finally, we will get one index called, that is called the soil rating index, SRI. That is nothing but multiplication of all this, A into B into C into X. So you will get one thing. So based on this, our SRI has given range from SR. The stories are given range called 0 to 100, and those soils are completely divided into how many types? Excellent, good, fair, poor, very poor. So these are the things. So SRI ranges from 0 to 100, and those soils are completely given ratings. What are those? If you given up to 0 to 100, he given rating, and he put the soils under the which how many category, how many cadres? Excellent soils, good soils, fair soils, poor soils, very poor soils. So like that, he given one index. That is called the stories index. And remember, students, this one very important, particularly mentioned in your syllabus. Soil rating index, very important. Next one. And what is this rating? Grade 1, very excellent. Very excellent. If the SRS soil rating index was between 80 to 100, means that is very excellent condition. These type of soils are suitable for wide range of crops. We can grow any type of crops. We can grow alfalfa, some orchard crops, from horticultural crops to field crops. Some all type of crops we can go grown in this type of grade 1. And grade 2 student, that is a very good condition. It is somewhat better. Just you think this is a first rank, this is a second rank student. So okay, grade 2 it is a good. Here SRF soil rating index, it's around 60 to 79% students. Suitable. Here also you can grow. We can grow for mostly soils. We can go for all type of conditions of the soil. Whereas grade 3, it is a fair students. Fair conditions will be there, and soil rating will be around 40 to 59%. And generally a fairly fair quality of or less wide range of crops. We can grow some very light, not that much good, not that much crops can compared to these two. Not that much crops we can't grow, but we can grow up to some sort of crops here also. But grade 4 student, that is poor condition will be there. Only the rating of SRI soil rating index is around 20 to 39%. We can grow very narrow crops. We can grow very limited crops we can grow. But in grade 5, here it is very poor students. The soil rating index is 10 to 19. It is very limited use expected for pasture. We can go only from grass, all those things. Especially in my area, some sort of lands comes and I can give this rating. I didn't do any analysis, but most of them are good soils for growing only pasture. Coming to grade 6, it is non-agriculture purpose. Tar lands, rating of SRI was very less. Steep broken lands, river washes, soils, etc. So all the wastelands will come under this SRI, which is less than 10%. It comes under the non-agriculture purpose. There is also the given how many grades, 6 grades are there. These are the classes, these are the rating, and these are the description about this type of grades. Okay, student. This is stories index and soil rating index given by the stories. Coming to the next, productivity rating. This is called the Ricker index, soil productivity index. This is what index? This rating index. This is productivity index. So students, it is a modified version, students. When compared stories and Ricker is somewhat very similar, but Ricker was completely modified the stories index. It is somewhat related to the productivity of the soil or capacity of the soil to produce certain amount of area, a yield. It is a capacity, how much yield can be given by the particular soil. This is what called the soil productivity index, SPI, productivity index, soil productivity index. So what are the two types of productivity? Present productivity, what is that? Productivity without any improvement. So it is nothing but, and another one is called potential productivity, capacity of the soil to produce a crop when all improvements are made. Just you can improve like this, students. This is you can compare when you write an exam without going for any preparation. This is nothing but by taking good training and good preparation. This is called, you can compare like that. Okay, students. So this is a present productivity, means productivity without any improvement. Potential means potential. You have very good potential, but you didn't read anything. You didn't go for any preparation, but blindly written. But you have internally have a lot of potential. So this potential will come out. When it will come out, the particular soil or it is capacity of the soil to produce crop when all improvements are made. So productivity depends on mainly inherent soil characteristics, students. What are those? Moisture. Remember these words, students. These letters are very important, because when you become suppose if you got a very good position in a soil survey department, you should know all these letters. So such as moisture H, drainage D, effective depth P, texture T, base saturation N, soluble salt content S, organic matter content O, mineral reserve M. So these are the important. Depend upon these characteristics only we can go for soil productivity index. Now we will see what is that. The present productivity is found out multiplying the percentage of inherent soil character. So present productivity without making any development, just we will do. H means, what is the meaning of H? Moisture. So by moisture we will convert into percentage, and we will do all those things. We overall will take percentage and we will get something regarding this present productivity percentage. Potential means after this same thing we'll do, but after giving some improvements, after giving some emeraldations, after improving the soil conditions, we will go for this calculations. Okay, students. Now these are the require giving properties, students. So working on the present productivity potential. Now calculation P is 19%. So we have got all this percentage. So there is a rating. If the after calculating all this, if the product, if it comes under this, if the soil productivity rate comes under 65 to 100, you can say it is excellent. If it is a good, you can come up to rating 35 to 40 to 64. Average means you can give rating up to 20 to 30. Poor means 8 to 19. All are percentage on students. Extremely means 0 to 7 students. So these are the classes. These are the productivity classes. Excellent, good, average, poor. The H means just after just improving, showing if 70 to 80 will be there. These are the after improvement conditions only. Just coefficient, all this calculation, but you remember this table. This derived after improving, after doing some experiment. So this is regarding the soil productivity index. So FAO panel, students, another important land evaluation by giving the food and agriculture. So different land evaluation present or different categories in there. So FAO are given 2 orders, students, just like our taxonomy orders. They are also given two orders. What are those? Yes, N. What S means suitable for land evaluation. N means unsuitable, not suitable. They are also given 3 classes reflecting the degree of suitability. They are also given 3 classes. What are those? S1, S2, S3 under the S. So S1, S2, S3 comes under the suitable land classes. N1, N2 comes under the N, which is not suitable or unsuitable for the land evaluation. Subclass also reflect the kind of limitations. And if there is any limitation, what are the limitations? So if you have any limitation, suppose S1 has some limitation. S1, we keep subscript C means that particular soil has limitation with some climate. That is called the subclass. So what are the subclass? Climate, topography, wetness, salinity, sodicity. F means soil fertility. S means physical condition of the soil. So naturally, students, just I'm giving examples here. You can see there are indication by symbols using the lowercase letters following the Arabic numbers. See, students, just now I said S2 means suitable. W means wet, there is a wetness problem is there. 2, this 2 S2. So we have some problem. That meaning that soils are suitable, moderately suitable. So A2 means moderately suitable. Wetness is the limitation. That is the meaning. So if I write like this in a map, this is the meaning. So soils are suitable. Yes, is there, but moderately suitable. I given 2 moderately. So S2 means moderately suitable. Moderately suitable. Wetness is the limitation. See, I given W as a wetness is the limitation, which unit level of 2. This is unit level of 2, which is unit level of 2, which indicates that the land development unit have minor difference in management requirements. So it needs some minor difference will be this for limiting. So these are the FAO panel of panel explanation. This is not up to event, but this is very important. You know, the stories index, recur index, I remember. This one also is very important, but this is not there in your syllabus, but I'm giving you, but these are all in your syllabus. So anyhow, students, thank you very much for your patience. So this is my quotation for today. You are weak or strong? Your students, you should say, are you weak or strong?